Hey guys, so far we started with a new chapter, that is refraction of light on curved surfaces. Today we are going to look at what exactly is the physics behind what happens. So when we saw the activity yesterday, right, how the arrow just flipped over. So we are just going to look at diagrammatically how do I show that on paper to understand it simply, right? So we learned something yesterday called medium. If you remember, we said light, whenever it goes from one medium to another medium, it tends to bend, right? uh, for our case yesterday the medium was air and water. Okay, I'll just repeat, medium is nothing but the path or the let's say the matter through which light is passing. Okay, air is one, water is another, glass can be one more, right? So the thing about mediums is they are different from each other in a manner that one can be dense, right? If you know dense, it means like a little more packed, so there's not much space in between the matter over there, right? Kind of imagine it like this, like an empty road and a busy road, right? It's always, we slow down when we go on a busy road and we go fast when you're on an empty road, right? Similar to that, light will go faster when the medium is empty, as in when it is rarer. But once the medium becomes dense, it changes into a different one, it goes a little slow, right? It goes a little slowly, and because of that it tends to bend and change its direction. Now, how this changing happens and all, we'll figure out through diagrams. Okay. So, if I have to look at a curved surface, it would look something like this, right? This should remind you of some other diagrams that we have drawn before. Okay. Say that light is going from here, hitting the surface. Alright, I'm going to assume that this side is air. Okay, light is going through air. Suddenly it hits a glass. This is the surface of the glass, which is filled with water. Okay. Now, what happens is, if you remember, this is like a curved surface, curved mirrors. Remember in mirrors we did diagrams, right? Kind of like that. Okay, so this is the surface. Now, light will not go straight through once it hits this. Okay, so since it is water, I'll just like kind of maybe put some dots here just to denote that it is water. Okay, now what's happening is, for all the light that goes through, remember that for every curved surface there is something called a pole. You remember we did pole in mirrors, right? There is going to be a pole for this also. Along with that, there is also going to be a center of curvature and a whole principal axis, right? It's basically the same diagram that we drew for curved mirrors. Only difference over here, light goes through the mirror, or since it's not a mirror, it's matter, it just goes through. Okay, and there will be definitely a focus also somewhere here, but right now not necessary, since we're just trying to understand what is happening. Okay, so we know one thing, that this curved center of curvature is nothing but the point from which you can draw a normal, right, to where the light is meeting the surface of this curved surface, right? So I know that from wherever my light comes, it will behave only as per the that normal to that point. Okay, just keep in mind every curved surface we are going to draw something like this. Right, there is going to be a curved surface. Okay, there is going to be a medium. Okay, rare medium is like air, denser medium is like water. Okay, so I'll just take one example and run with it. Assume that this is the pole, this is the center of curvature. Okay, now what happens to the light that is going through it? So say this is a ray of light, say that this is the R1. Okay, now you need to keep one thing in mind: from which medium is it going towards which medium. If you figure that out, it's very easy to do. Okay, now there is a certain angle over here between these two. Right, generally in reflection, once it strikes, it will have the same angle to bounce back, but this is called refraction, so there is a slight difference. What happens is, if it's from rarer to denser, this angle is going to reduce. Okay, so this angle, if you see, it is much less than this angle. Light went through, but it bent in such a way that this angle gets reduced. Right. So whenever light goes from rare to dense medium, that is what happens. The light is going to bend towards the normal. If you see, angle reduced means it's coming close to the normal. Okay, so I'll just make a side note here. From rare to dense is nothing but light bend towards normal. Normal is again this dotted line. Okay. The opposite is true also. If it goes from dense to rare, then again it will bend away from the normal. Okay, so that pretty much applies there. So now if I look at this, does this not look like a convex surface? If you remember, we saw convex mirrors, right? The outer part is convex, the light is hitting the convex side. So this case is when light is going from rare to dense medium and hitting a convex surface, just like our glass example yesterday. Okay, now over here also you have both the convex and the concave examples also. Alright, what would this example B if it's on the opposite side. Okay, what's the flip side to it? I'll draw it on this side. Imagine that this is the same glass and this is the ending of the glass. Okay, the other side of the glass. Now this side is dense, this side is rare. Okay, there is still water, there is the air exiting from this thing. Now what's going to happen to the light over here? And again I'll assume pole is here, C is over here. Okay. Now if there is a ray of light like this, okay, now this C pole, the normal is drawn from there. Now what's happening is the light is going from dense to red. Keep in mind the ray is still parallel to the axis. So here also parallel, here also parallel. Now like I said, when it goes from rare to dense, it will bend closer. But if it goes from dense to rare, then what's going to happen? It should be the opposite, right? It should bend a little away from the normal. So this angle, whatever is there, it is going to increase. Okay. So basically it is going to diverge a bit in that direction. Okay, light is bending away from this line, away from this line. So this angle, if you see, has increased, right? So whenever you go from dense medium to rare medium, it is going to increase its angle. Now keep in mind, this is a concave surface, this is a convex surface. Okay, but we covered both the cases for rare to dense and dense to rare. Okay, so that's about it for this class. Alright, okay, thank you. I'll see you tomorrow.